Good morning to one and all. So welcome to the channel Firjan. See, 12th standard first lesson electric charges and electric fields. In this one, 12th video about Gauss law and its applications. Before that, we discuss electric flux. Electric flux means pi E. How to represent na pi E? Pi means flux, E means electric. So means electric flux. So electric flux means the number of electric field lines passing perpendicular to plane surface. We call it as electric flux. For example, here we can consider small area. This is the small area. It is the area vector dA. dA is the area vector. Small area we can write dA. See here electric field. This is the electric field E, which makes theta angle with area vector. See actually electric field has two components. One is along the area vector, another one is perpendicular to area vector. See here this is E sin theta, this is E cos theta. E cos theta. What is the here flux na? Number of field lines passing perpendicular to plane surface. This is the plane surface. See for example this is the plane surface. Electric field lines, this one, these are the perpendicular to plane surface. So electric field lines perpendicular to plane surface means electric field lines along the area vector. So that is, see here we can write flux equal to what? Now small area, so small flux. So flux equal to what? Electric field lines means electric field into dA. Why not here? Electric field lines perpendicular to plane surface, which is area vector is perpendicular to plane surface. Which one is whatever the electric field lines along the area vector, that we can take here. So E cos theta dA. See this we can write E dA cos theta. E dA cos theta. Actually in vectors A vector dot B vector. What is the formula na? AB cos theta. AB cos theta. See here E dA cos theta. Like that is there na? We can write here d pi equal to E dot dA means electric field vector dot area vector. Electric field vector dot area vector means electric flux. What na formula here? E dot dA. E dot dA. Why na here small flux? So electric field and area vector, small area vector. See for example here total flux na, so pi equal to integral d pi. So that means integral d pi means E dot dA. E dot dA. See here E constant we can write outside na, so pi equal to E outside integral dA. Integral dA means A, so pi equal to E dot A means electric field vector area vector means dot product of electric field vector and area vector, the resultant is the electric flux. Electric flux is the scalar quantity. Why? Because dot product here. So electric flux is scalar quantity. Electric flux is scalar quantity. See this one, see here electric flux means the number of electric field lines passing perpendicular to plane surface, that we can write mathematically pi equal to E dot A. E means electric field vector, A means area vector. It is a scalar quantity. Its unit is Weber per Weber only. What is the unit of electric flux na? Weber, or we can write Newton meter square per coulomb. Newton meter square per coulomb, or we can write it as Weber. This is the unit of electric flux. This is unit of electric flux. Now we discuss Gauss law. See what is Gauss law now? See total number of electric flux passes through closed surface is 1 by epsilon naught times net charge enclosed by the surface. I will write here statement. So what is the Gauss law now here? See Gauss law. Gauss law. What is Gauss law now here? The net electric flux or total electric flux. The net electric flux passes through net electric flux passes through closed surface. Closed surface is 1 by epsilon naught times 1 by epsilon naught times the net charge enclosed by the surface. The net charge enclosed by the surface. This is the Gauss law. See what is the statement of Gauss law? Na? The net electric flux means total electric flux passes through closed surface is 1 by epsilon naught times the net charge enclosed by the surface. So that we can write mathematically. See, pi closed equal to q inside by epsilon naught, that we can write integral E dot dA. Integral E dot dA closed surface na we can write here circle. So that means closed surface. That means closed surface. This is the statement of Gauss law. See what is the statement of Gauss law? The net electric flux or total electric flux passes through closed surface is 1 by epsilon naught times the net charge enclosed by the surface. That we can write pi closed surface. Pi means flux. Flux through closed surface equal to total charge inside the closed surface by epsilon naught, that equal to we can write integral E dot dA, electric field vector dot dA vector, integral of closed integral of electric field vector dot area vector dA vector. So that is called as statement of Gauss law. This we can write, we can prove this one. See, for that we can write, for proof we can take spherical surface. See here, this is the closed surface. Yes, now here plus q charge is there. Due to this plus q charge, here see electric field lines how it is. So away from the charge means radially outwards. Why? Because positive charge na electric field lines is away from the, means electric field is outward. See, radially outward. Due to this electric field is outward. This is the electric field. See, due to this, see here this side electric field. This is the electric field. See here this one. See, electric field is outward. So radially outward electric field because of positive charge. Means this electric field passes through, electric field lines passes through this closed surface. See here, we can select here small area, this one. This area vector is this one along the electric field. So this is dA, means area vector for closed surface is only outward normal is considered as area vector. That's why this is the area vector. dA is the area vector for this small area. So this we can take this area na, this area vector is dA. For this area na, area vector dA. See here, for this area small area, this is area vector. See here in this one, area vector and electric field both along the same line, so means parallel to each other. Here what is the angle na? Angle between electric field vector and area vector is 0, theta equal to 0, theta equal to 0. Here also 0, here also 0, here also 0. See here, we can write from this. See, due to this area, what is the flux through this one na? So d pi equal to E dot dA. E dot dA means electric field vector and area vector. See here, E dot dA na, d pi equal to E dot dA. So E dA cos theta we can write. So cos theta is what here? Theta is electric field vector and area vector. Both are in same line. So that's why theta is 0. Cos 0 na 1. So what we can write? E dA is the electric flux through this small area. This one same EDA. This one EDA. This one EDA. Means how many is there here? That type of infinity is there. We can take integral d pi equal to EDA, integral of EDA, closed surface na, we can take here closed surface. So EDA. See here in this one, E means, see, due to this plus Q, what is the electric field in this point? Means that point means r distance from the charge, or distance from the charge. What is the electric field na? I write here E electric field equal to 1 by 4 pi epsilon naught q by r square. This is the electric field due to plus q charge at all distance on the surface, closed surface, at small in this area. So what now here? 1 by 4 pi epsilon naught q by r square. Not only here, here also same, here also same, here also means every point on this one electric field is 1 by 4 pi epsilon naught q by r square. Instead of, see here, E is constant now, we can write outside. See E, we can write outside. So dA, integral dA. So E integral dA means A we get, means E A. So E means here what? 1 by 4 pi epsilon naught q by r square. A means area of the surface. So means surface means here 4 pi r square. Right here, 1 minute. See here, integral pi means here pi. So pi equal to here, E means 1 by 4 pi epsilon naught q by r square. See 1 by 4 pi epsilon naught q by r square into area of the surface na. See here 4 pi r square. 4 pi r square. See r square means here capital R we can take. Here also capital. Why now radius here is capital R. See this capital R square cancel. 4 pi cancel. What we get here? Pi equal to q by epsilon naught. This is the Gauss law. See what is Gauss law here? Pi closed equal to q by epsilon naught. Q means here inside the closed surface. So inside the closed surface, what here q? So q by epsilon naught. Pi equal to total flux through closed surface equal to 1 by epsilon naught times net charge enclosed by the surface. Net charge enclosed by the surface. This is the Gauss law. See again once. So what not Gauss law? The net electric flux passes through closed surface is 1 by epsilon naught times net charge enclosed by the surface. This is the mathematical representation. Pi closed equal to q inside by epsilon naught. That we can write integral, closed integral. So E dot dA. See here we can take here closed surface plus q is inside. So due to this electric field radially outwards. See here we can select small area dA. This area vector is always for normal to the outward normal. So that's why it is area vector. See area vector and electric field both are parallel. So parallel means theta equal to 0. See what? Due to this area, what is the flux passes through this area is d pi equal to E dot dA. E dA cos theta. Theta is what? 0. E dA we can write. So d pi equal to E dA. Here d pi, here d pi, here d pi, here d pi. Totally now what we can write? We can take integral. Integral d pi means equal to integral E dA. E is the constant, electric field is constant. So integral A. Integral dA means A. See E means here at this point, what is the electric field due to this plus q? That is 1 by 4 pi epsilon naught q by r square. Here I write 1 by 4 pi epsilon naught q by r square into area of this na, surface na, 4 pi r square. This r square cancel, 4 pi cancel. What we get na? Pi equal to q by epsilon naught. See pi equal to what? Q by epsilon naught. Q means here inside the closed surface. Inside the closed surface. This is the proof of Gauss law. This is the proof of Gauss law. See next we discuss what are the, in this one, some or the point means some properties we discuss here. See this Gauss law. See here we can take closed surface now. This R value increased means size increase the closed surface. For example, see this is the closed surface. This radius is R. Here plus Q charge is there. Due to this, what is the flux through this one now? We write here pi equal to Q by epsilon naught we get. So this area means this radius we can increase now, size increases. See for example this size. So what now? This is before R now 2R. What is the flux through this closed surface now? Q by epsilon naught. Means we can increase this area. See again, I increased this area. So means see closed surface now size increases. So this we can take it as 3R for example. What is the flux through? Passes through this closed surface due to plus Q now pi equal to Q by epsilon naught. Means size of the closed surface do not affect the net flux. Right here note, see what now here, size of the closed surface, closed surface do not affect the net flux. Net flux. So means size increases, net flux does not change. So do not change means size of the closed surface do not affect the net flux. See next one. See we can take different shapes, closed surfaces. See this is cylindrical closed surface. See next one here we can take a cubical closed surface. So cubical na here this is the cubical closed surface. See, we can take conical closed surface. See, conical closed surface. See, conical closed surface. See here, these are closed surfaces. See here, we can place charge plus Q. At center, we can place plus Q. Here, we can place plus Q. Due to this electric field lines, this one. See this side, this side. See this side, electric field lines. See here, means electric field lines means flux passes through this closed surface. Here also see flux passes through closed surface. This one, flux passes through closed surface. See here, electric field lines. Here see. So means electric flux through closed surface is q by epsilon naught. So do not affect. Means here what we can say now, from this we can say electric flux through closed surfaces do not change due to shape of the object, shape of the closed surface. Means see here I write one more, shape of the closed surface, shape of the closed surface do not affect the net flux, do not affect the net flux. Understood now this one? See, size of the closed surface also do not affect, and shape of the closed surface also do not affect. This is closed cylindrical shape closed surface, cubical closed surface, conical closed surface, but flux passes through this closed surface is q by epsilon naught. Q by, so flux through closed surface equal to q by epsilon naught. So means flux through closed surface does not change, do not change due to shape of the closed surface or size of the closed surface. Yes na? See next. Some cases we can take, first case we can say, see here, for example we can take closed surface. This is the closed surface. Here charge is outside is there, before and all charge is inside the closed surface, now outside is there. What is the flux through this closed surface? See here, electric field lines due to this charge radially outwards. See like this electric field lines passes. See like this electric field lines passes. So what is the flux through this closed surface due to outside charge? See here we find out, due to outside charge plus q, what is the flux through this closed surface, that we find out. For that what we can do, here we can take small area. This is the electric field vector, electric field vector, it is the area vector, both are in same direction. What is the flux to this one? Flux equal to pi 1 equal to e dot dA, e dot dA. Why not here small area we can write, small small area we can select e dot small means dA. See here e dA cos theta, e dA cos theta, e dA cos theta means here theta is the angle between electric field vector and area vector. What is the angle here? 0. Theta equal to 0. We can write here cos 0. So cos 0 means 1. See what we get now, e dA. What is the flux through this area na? EDA. See here we can take this area. See this one area vector is outward normal. See this is area vector. This is the electric field direction. See both are in opposite direction. What is the angle here? 180 degrees. So we can write flux through this area. See what now, pi 2 equal to E dot dA. E dot dA. Here what we can write, E dA cos theta. See theta is it for what? 180. So means E dA cos 180. Cos 180 means minus 1. See we can write minus E dA. Flux through this area is minus EA, through this area is plus EA. Total flux na pi equal to pi 1 plus pi 2. pi 1 plus pi 2. Pi 1 is what here? Minus, sorry, plus EDA, pi 2 is minus EDA. So plus EDA minus EDA 0 means flux through closed surface when charge is outside. What is the flux through closed surface? Not 0. Flux through closed surface when charge is outside is 0. That case is 0. So this also same. It is outward normal. So this is flux EDA. So this one, this direction is area vector. This direction is electric field vector. Here also flux through 0. Here also 0. Flux through closed surface is 0. Means from that what we can say, when the charge is outside the closed surface, what is the flux through the closed surface means 0. Flux through closed surface is 0. This is the first case. See, second case, flux inside the surface. Flux inside the surface. See, second case, flux inside the surface. See, second case, case 2, we can take flux, sorry, charge inside the surface. Charge inside the surface. Charge before charge outside the surface, first case. Second case, charge inside the surface. See, this is the closed surface. Here q1, q2, one charge is outside, is there q3. Due to these charges, flux through this closed surface, electric field length passes through this closed surface. So electric field length passes through this means flux is passes through this surface. In that case, what is the flux through this surface, that we find out. For that, flux equal to flux in closed surface. Closed surface equal to q inside by epsilon naught according to Gauss. What is the q inside? Q1 plus q2 means q1 plus q2 by epsilon naught. This is the flux through this closed surface. See here, due to this outside charge, so due to this, what is the flux now? This one 0, but inside charge is there, because of that we can write q inside means q1 plus q2 by epsilon naught. But here flux through closed surface equal to, what is the formula? E dA. So means here E is electric field. This electric field is due to inside and outside charges. Inside or outside means, and outside both charges, inside and outside charges. Due to that, what is the electric field through this one? So that is due to inside and outside charges, both are involved. Both are involved. So that is, it is same on the surface of the closed surface. Yes, na? So means second case, charge is inside the surface and some is outside the surface is there. What is the flux through this closed surface? Na? Flux through closed surface equal to q inside by epsilon naught. Q inside is q1 q2, so means q1 plus q2 by epsilon naught. See here, flux now through closed surface equal to integral E dA. This E is due to inside and outside charges, due to inside and outside charges. This is the second case. Third case, see, electric dipole is placed inside the closed surface. What is the net flux through the closed surface? See, electric dipole is inside closed surface. Inside closed surface. This case, what is the flux through closed surface? See, this is the closed surface. See here, in this one dipole is there. Dipole means minus q plus q is there. It is. See, what is the flux through closed surface according to Gauss? See, phi closed equal to q inside by epsilon naught. Q inside by epsilon naught. What is q inside? Minus q plus q. So means minus q plus q by epsilon naught. Minus plus cancel, what we get? 0 by epsilon naught. So what is the flux through closed surface is 0 when electric dipole is placed inside the closed surface. When electric dipole is placed inside the closed surface, what is the net flux through closed surface is 0. This is the three cases. In this one, see, what is the important point now here? See, this Gauss law is applicable only applicable. What is the now important one here? See, Gauss law is only applicable, always not useful. Not always. In particular case only we can use this Gauss law, not always useful. So that's why we can say that Gauss law is only applicable, only valid for applicable only, always not useful. What are the this one properties? Some properties is there. What are the first one? See, in this one, electric flux through closed surface or Gaussian surface is, that means the flux through Gaussian surfaces or charges through Gaussian surfaces, charge distribution is same. Flux through Gaussian surfaces, about Gaussian surface, same. Throughout the surface is same. So means flux through Gaussian surface. See what are the first one? Gaussian surface properties. See, Gaussian surface should be symmetric about charge or charge distribution. Means along Gaussian surface, same charge distribution is there throughout the surface. So means that means we here Gaussian surface. Gaussian surface should be symmetric about charge or charge distribution. See here, Gaussian surface should be symmetric about charge or charge distribution. On Gaussian surface, charge will be distributed equally. Equally. See second one. See the electric field must be symmetric. Symmetric means same or equal or constant at all points of Gaussian surface. See again I repeat here. See electric field must be symmetric. Symmetric means same, equal or constant at all points of Gaussian surface. Elsewise, Gauss law is applicable only, not always useful. The same way, elsewise, Gauss law is applicable, not always useful. Not always useful. See, first one is Gaussian surface should be symmetric about charge or charge distribution. For charge distribution, Gaussian surface should be symmetric, same, equal, constant. Second one, electric field must be symmetric. Symmetric means same or equal or constant at all points of Gaussian surface. For example, this is the Gaussian surface, this point, this point, this point, this point, any one point, electric field is same on Gaussian surface. See third one, the theta means theta is the angle between electric field and area vector. See here the theta, third point, the theta must be same at all points of Gaussian surface. The theta means angle between electric field vector and area vector. Electric field vector and area vector. The theta is either 0 or 90 only always. See here, the theta means angle between electric field vector and area vector. The theta must be same at all points of Gaussian surface. On Gaussian surface, theta is same, either it is 0 or 90, either it is 0 or 90. See fourth one, Gaussian surface should not pass us through point charge. This is the important properties according to Gauss law. See first one, So what is the note now? Gauss law is only applicable always, not useful. It is only applicable. Particular case only we can use, not always. So that's why it is applicable, not useful. See second one, Gaussian surface should be symmetric about charge or charge distribution. See electric field must be symmetric. Symmetric means same, equal, constant at all points of Gaussian surface. On Gaussian surface, every point electric field is same. So elsewise Gauss law is applicable, not useful. See, theta must be same at all points of Gaussian surface. Theta means angle between electric field vector and area vector. The theta is either 0 or 90. Gaussian surface should not pass us through point charge. Should not pass us through point charge. See, before we discuss, note important one. See, flux through closed surface is always 1 by epsilon naught times net charge enclosed by the surface. That is Gauss law. See here, size and shape of the closed surface do not affect the net flux. Do not affect the net flux. Means size increases, size of the closed surface increases, or a different shape is there, but flux through the closed surface is q by epsilon naught only. Q by epsilon means that's why net flux do not affect due to size and shape. Due to size and shape. These are the properties, note points about Gauss law. See, now we discuss some problems and applications. Here we discuss some applications of Gauss law. See, first one we can take semi-cylindrical surface. Semi-cylindrical surface. See, first one we can take semi-cylindrical surface. So this is the semi-cylindrical surface. See, this is semi-cylindrical surface. Here charge q is there. See, what is the flux? Find flux through semi-cylinder, that we want to find out. For that, what we can do now here, we can draw the imaginary, means closed surface. See, this is the closed surface. See now, what is the flux through this closed surface? So flux through closed surface equal to q by epsilon naught. Q by epsilon naught. Semi cylinder na we can take half, means half part only na. So means pi equal to q by 2 epsilon naught. This is the flux through semi cylinder. Semi-cylindrical surface. Semi-cylindrical surface. Flux through closed surface na q inside by epsilon naught. What is the q here? Inside charge is q. So that's why q by epsilon naught. Semi-cylinder na, so we can take half 1 by 2 into q by epsilon naught. So means q by 2 epsilon naught. What is the flux through semi-cylinder na? Q by 2 epsilon naught. See, second we can take semi-sphere, means hemisphere. See this one. See this, here we can place the charge. What is the flux through this hemisphere? See, we can complete the means closed surface. This is the sphere. This case, what is the flux through this closed surface na? Pi equal to q by epsilon naught. See here what? Hemisphere. So means half of part only. That's why flux through hemisphere is 1 by 2 into q by epsilon naught. From that, what we can write? Pi equal to q by 2 epsilon naught. What is the flux through hemisphere na? Q by 2 epsilon naught. Semi cylinder, pi equal to q by 2 epsilon naught. Hemisphere also same. Now we can say, take here plate. Plate only we can take here. See, thin plate. Here charge is there. In this one, see here, it means whenever closed surface is there, that case we can write Gauss law. So in closed surface, net flux through closed surface is always 1 by epsilon naught q inside. Here not closed surface. This type of we can arrange six plates now. So then it will be closed surface like a cube we get. Now see here, we can arrange like this. This is a closed surface now this one. See, in this case, electric field lines passing like this means electric flux passes through this surface is what now? Flux through closed surface is q by epsilon naught. Here how many plates is there? One plate only. But here closed surface means 6 is there. 6 plane surfaces is there. So due to 6 plane surfaces, q by epsilon naught. Each plate na flux through each plane surface or plate. So what na? Q by 6 epsilon naught. What is the flux through this surface only na? See what na this surface. So charge is at center is there. So we can draw the closed surface like this. We get what is the flux through closed surface? Q by epsilon naught. Here how many is there? 6 plates we can arrange. So that means each plate means or each plane surface means Q by 6 epsilon naught. Q by 6 epsilon means flux through this surface, plane surface or this plate. What na? Q by 6 epsilon naught. Q by 6 epsilon naught. For example, see here cubical surface we can take. So this is the cubical surface. See. So cube has 8 vertices is there. See in this vertex, here we can place cube. It is open surface now. This type of will be arranged like closed surface. How many we require now? 8 cubes required. So 8 cubes will be arranged like closed surface. That case it will be in center is there. So that case flux through 8 cubes equal to q by epsilon naught. Each cube na see flux through each cube equal to q by 8 epsilon naught. Q by 8 epsilon naught. For example, see this plate is shaded. What is the flux through this place now? That case, see here flux through each cube is q by 8 epsilon naught. Q by 8 epsilon naught. Here this plate is shaded, so mean this type of will be 8 is there. In this one 3 faces will be outside is there, 3 faces will be inside. That's why we can multiply with what are the faces outside is there, that only closed surfaces is there. That's why we can write 1 by 3. What is the flux through this is shaded surface when the charge is at vertex na? That case q by 8 3 are 24 means 24 epsilon naught. This very important. See when the charge is at vertex of the cube, here not shaded, only cube is there. That case what is the flux through each cube na? Q by 8 epsilon naught. Why we are writing na? So means 8 cubes we can arrange one above the other like closed surfaces. So it will be center is there. That case it will be act as closed surface. So closed surface na flux through closed surface. For getting closed surface, how many cubes we are using? 8 cubes. So flux through 8 cubes creates closed surface. That case, what is the flux through closed surface? Q by epsilon naught. Each cube na flux through each cube equal to Q by 8 epsilon naught when the charge is at vertex only. When the charge is at vertex, that's important. When the charge is at vertex, that case, what is the flux through this cube na? Q by 8 epsilon naught. In this one face will be shaded. That case, what is the flux through? Passes through this shaded face na? That case, what na? Pi equal to q by 8 epsilon naught. How many here is there? 8 faces, 8 cubes is there. In this one, 3 only outside. For each cube, 3 only outside is there. Remaining 3 will be inside is there. So that's why 3 faces na? See here 1 by 3 we can write. So means q by 8 epsilon naught into 1 by 3. 8 3 are 24. What is the flux through this shaded surface na? Or shaded face na? So pi equal to q by 24 epsilon naught. Pi equal to q by 24 epsilon naught. 24 epsilon naught. These are the applications. See first one, semi cylinder. What is the flux through semi cylinder? Pi equal to q by 2 epsilon naught. Hemisphere, pi equal to q by 2 epsilon naught. Only one plate. That case, what is the flux through each plate or each plane surface? Q by 6 epsilon naught. Flux through when the vertex means charge is at vertex. That case, what is the flux through now? Q by 8 epsilon naught. One face will be shaded now. That case, what is the flux through this cube when the charge is at one vertex na? Pi equal to q by 24 epsilon naught. Each cube na q by 8 epsilon naught. So each cube 3 faces only outside is there. So that case we can write 1 by 3. So what is the total flux through this shaded face or this shaded surface na? Q pi equal to q by 24 epsilon naught. 24 epsilon naught. See now, so we can take what is the flux through container of the curved surface. container of the curved surface and curved surface of the cylinder. When the charge is at inside the cylinder, so that we find out now. First see flux due to Q through curved surface of cylinder. See what is the flux through? Find flux through. Find flux through curved surface of cylinder due to Q. Due to Q. For example, see this is the cylinder. Here Q charge is there. Due to this charge, what is the flux through this surface, curved surface only? For that we can draw here cylinders. See this one cylinder, this one cylinder, this part we can remove. Next, what is the flux through this one? So that only we find out. So what is the flux through this curved surface only? That only we find out. For that, see flux through cone. Now what is the flux through cone? Now here see, for this we have formula. So flux through cone is pi equal to q by 2 epsilon naught into 1 minus cos theta. This is the flux through cone. Flux through cone pi equal to what? Q by 2 epsilon naught into 1 minus cos theta. Here see, here two cones is there. Flux through two cones now. So what we can write? See 2 into cone means here q by 2 epsilon naught into 1 minus cos theta. See 2 cancel. So means flux through two cones. Now here q by epsilon naught into 1 minus cos theta. So we want what is the flux through curved surface? Means flux through closed surface. Now I write here flux through closed surface. Closed surface means this one, closed surface. So what is the flux through closed surface? Q by epsilon naught according to Gauss law. So we want flux through curved surface. Curved surface, we know cylinder, so means sorry cone. So flux through cone is q by 2 epsilon naught 1 minus cos theta. Here two cones is there, this cone and this cone we can remove. Then we can get the what is the flux through curved surface. So for that, flux through two cones is q by epsilon naught into 1 minus cos theta. Here only curved surface means flux through closed surface minus flux through two cones. So we get the flux through curved surface. So flux through closed surface is q by epsilon naught minus flux through two cones q by 2 epsilon means q by epsilon naught into 1 minus cos theta. 1 minus cos theta. Here see, so semi vertical angle na, here theta equal to what? 45 degrees. Instead of theta we can write 45 q by epsilon naught minus q by epsilon naught into 1 minus cos 45 means 1 by root 2. Yes na? See multiply this one. See I write here q by epsilon naught minus into 1 na, minus q by epsilon naught minus into minus plus q by root 2 epsilon naught. This q by epsilon naught cancel. What is the flux through curved surface na? We get q by root 2 epsilon naught. What is the flux through? Only curved surface na, curved surface of the cylinder na. See flux through curved surface of cylinder is q by root 2 epsilon naught. Root 2 epsilon naught. See flux through curved surface of the cylinder is q by root 2 epsilon naught. Root 2 epsilon naught. See again once, find flux due to q through curved surface of the cylinder. For that we can draw, this is the closed surface, cylinder is, here we have two cones is there, two cones. What is the flux through these two cones? We can remove from the total closed surface, we get the flux through curved surface. For that, first what is the flux through cone? So that we can write pi equal to q by 2 epsilon naught into 1 minus cos theta. This is the flux through this cone. So here how many cones is there? Two cones is there. Flux through two cones. So 2 into q by 2 epsilon naught into 1 minus cos theta. This 2 cancel. What we get? Flux through two cones is q by epsilon naught into 1 minus cos theta. Flux through total closed surface na q by epsilon naught. So we want only curved surface. That's why we can write closed surface minus two cones. Closed surface is q by epsilon naught. Two cones is q by epsilon naught into 1 minus cos theta. Theta is here 45 degrees. When a semi-vertical angle here we can take this is 45. It is 90. Here again 45. So means what is the theta here? 45 degrees. See 1 by cos 45 means 1 by root 2. So q by epsilon naught minus q by epsilon naught into 1 minus 1 by root 2. So minus into 1 minus q by epsilon naught minus into minus plus q by root 2 epsilon naught. This q by epsilon naught cancel. What we get? Q by root 2 epsilon naught. What is the flux through curved surface of the cylinder now? Q by root 2 epsilon naught. Root 2 epsilon naught. This is the answer. Yes, na? Now see one more. Find flux through flux due to Q through curved surface of the container. Curved surface of the container. Curved surface of the container. See curved surface of the container na. See here, this is the container. See, this is the container. In this one, what is the flux through this container? For this we can have here. See, this is the cone. So now what is the flux through this cone? We find out first. Flux through cone equal to what now? Q by 2 epsilon naught 1 minus cos theta. Flux through closed surface. Flux through closed surface is container is closed surface na. So means closed surface is Q by epsilon naught. What we want? Find flux due to Q through curved surface of the container. Only curved surface. For that what we can write na? Flux through curved surface of container equal to flux through closed surface minus flux through cone. Flux through cone. See flux through closed surface na q by epsilon naught we know according to Gauss law. See, so means flux through curved surface equal to flux through closed surface is q by epsilon naught minus flux through cone is q by 2 epsilon naught into 1 minus cos theta. This is the flux through curved surface of the container. What is the formula na? Q by epsilon naught minus q by 2 epsilon naught into 1 minus cos theta. This is the flux through curved surface of the container. Only curved surface of the container. What is the formula? Q by epsilon naught minus q by 2 epsilon naught into 1 minus cos theta. Okay, these are the applications so of Gauss law. So thank you.